Okay, so remember in the last example that we were able to evaluate the volume bound by elliptic paraboloid from f of x equals 2x, g of x equals x squared. If you recall the region looks something like this. And initially we had it as a type 1 region. And if you recall, this was the function y equals 2x. And this was the function y equals x squared. Right. Now what we'd like to be able to do is, that was a type 1 region. We went up and down before. Okay, so that's type 1. What we're more interested in this time is making it into a type 2 region. Alright, so here's how we're going to do that. Same exact graph, nothing changes. So we have our linear function, we have our quadratic function. Instead, this is going to be x equals square root of y. So all we did was we just solved. And then we're going to do the same thing. And we're just going to solve, and we get that y over 2 is going to be equal to x. So those are our bounds. And this time we're going from left to right. Right? So it's a type 2 region. So as a type 2 region, notice that the lower bound, x, is going from y over 2 to the square root of y. And then all we're going to do is we're going to be able to solve to be able to find the bounds for y. So I'm just going to do that down here. We're going to set y over 2 equal to root y. We're going to square both sides. So we get y squared over 4 is equal to y. We're going to subtract y from both sides. So we get y squared over 4 minus y is equal to 0. We're going to factor out a y. So we get y over 4 minus 1 is equal to 0. And clearly, we can see that the two values for y are going to be 0 and 4. We're going to go back up. And we're going to say that y is bounded from 0 to 4. Alright. So, make sure that you understand that this is a particular type of region that can be expressed as type 1 or type 2. To be able to solve it as a type 2 region, we solve in terms of y, and then we get the bounds in terms of y. Now, we can take our domain D, and we're going to now set up a double integral based on D. So we're going to go down here, and our double integral is going to be the double integral. Remember, we go from the lower bound was y over 2, the upper bound was root y. We also know that the limits of integration were from 0 to 4 in terms of y. We still have x squared plus y squared. We went from x, so we went from left to right first, which was x, and then we went up and down dy. At this point, it's another trivial type of problem. We're going to have to do some computations, but it's not too bad. We're going to integrate with respect to x first. So we get the integral from 0 to 4. Antiderivative of x is going to be 1/3 x cubed. Antiderivative of y squared with respect to x is going to be x y squared. We're going to go from y over 2 to root y. And you can see now that this is going to be a little bit tougher than the previous, because now we're going to have some rational exponents that we have to deal with. Alright, we still have dy. We're going to substitute. We're going to use our fundamental theorem of calculus. It might get a little bit ugly, so hang in there. Just integration. 0 to 4. We have 1/3 root y cubed plus root y times y squared. That's the upper bound. The lower bound a little bit easier because there's no radicals involved with it. So that's going to be minus 1/3 y over 2 cubed plus, new line, y over 2 times y squared dy. At this point, we're going to go ahead and simplify this. Okay, so check your algebra as we're going along with this, because the algebra is a little bit tedious. We still have our integral 0 to 4. We have y root cubed. Okay, so think of that as y to the 1/2. So we have 1/3 y to the 3/2. We have 1/2 and we have y squared. That's going to be plus y to the 5/2. Okay, so check your algebra. Make sure that you understand how these first two work. Minus, we have 1/3. We're going to cube the 2. We're going to get 8. We're going to cube the y. So that should be y cubed over 24. We're going to distribute the negative. Y times y squared is y cubed over 2. We do have a dy in there. So just imagine that the dy is at the end. Clearly we can combine the y cubes. And we're going to get 13/24 negative y cubed. Alright, so before we finish this, in terms of y, we have 0 to 4. And then we're going to have 1/3 y to the 3/2 plus y to the 5/2 minus 13/24 y cubed dy. At this point, it's just a Calc 1 type of problem. All right, again, fairly tedious, but not too bad. We're going to add 1, divide by the new exponent. So we have 1/3 y, adding 1 to 3/2 is 5/2. We're going to divide by 5/2. Plus, we're going to add 1 to 5/2. That's 7/2 over 7/2. And then finally, we're going to have 13/24 times y to the 4th over 4. 0 to 4. All right, let's clean this up a little bit before putting it into the calculator. All right, so we're going to end up with 2/15. If we divide by 5/2, we're going to multiply by the reciprocal. So that's 2/15 y to the 5/2 plus 2/7 y to the 7/2 minus 24 times 4, 96, 13/96 y to the 4th from 0 to 4. All right, so the bad news is we got a bunch of garbage going on here with the rational exponents. The good news is that one of the bounds is 0, the other one is a perfect square. So it should turn out really nicely. All right, so I'm going to substitute and then I'm going to use my calculator. So we get 2/15, 4 to the 5/2 plus 2/7 of 4 to the 7/2 minus 13/96 of 4 to the 4th. Okay. Now technically there's a 0 in there, so we're going to say minus 0. And now what I'm going to do is I'm just going to shove this into my calculator. So just give me a moment. There might be a minute of dead air here while I'm stuffing this into the calculator. And I encourage you to do the same as I'm doing it, just to make sure that I'm okay with this. I get 216 over 35. All right. Now, I like that Because if we go all the way back to the first problem that we did with this, or we did it as a type 1 region, all the way up here, remember that we got 216 over 35 as a type 1 region. The volume has not changed. If you can see me, I'm actually shaking my hands. But the volume has not changed as a type 1 or type 2 region. It's just the way that we evaluate it. I'm certain that you would all rather have evaluated it as a type 1 region, just because it's a little bit easier. In fact, it's a lot easier because we're not dealing with these rational exponents. Okay. However, the good news is, after everything was said and done, now we know that there are two different ways to arrive at the same volume over a general region. In the next example, we're going to see one more to where we just have to decide whether it's a type 1 or type 2 region, because it's not always given as which one you should utilize.